Okay, let's get started with the next algebra video. This is chapter 3, section 4, solving multi-step inequalities. Before we get started with the examples, you've got a few notes to take, so write down what it says on this slide. And while you're doing that, let me explain to you that the steps for solving a multi-step inequality are actually the same as they are for solving a multi-step equation. The only difference is you have an inequality sign rather than an equal sign. So you start off with the first step and you use the distributive property. Then step 2, you combine like terms. Step 3, gather variables on one side. Step 4, undo addition or subtraction. And then step 5, undo multiplication or division. You just have to remember that rule that if you multiply or divide an inequality with a negative number, you have to reverse the sign. So just like we did the other day with the multiplication and division, same thing applies here. We just have more steps to follow. So let's take a look at the first example. 7 plus 6a is greater than 19. I have the steps here to remind us. Remember that the inequality sign separates the two sides. The variables on the left, along with a 6 and a 7. So we go through the steps. Remember, we only use them if necessary. So step 1, use the distributive property. There's no parentheses, so I don't need to do that one. Step 2, combine like terms. We'll look on the left. We have a number and a letter. Can't do anything there. On the right, all we have is a number, so we cannot combine any like terms. Gather variables on one side. We only have variables on the left, so we don't need to worry about that. Step 4, undo addition or subtraction. Well, the 7 is attached with addition, the 6 is attached with multiplication, so I want to undo the 7 first. Since it's a positive 7, I will subtract 7 on both sides. The 7's cancel. I bring down the 6a, bring down the sign, and then 19 minus 7 is 12. And the last step, undo multiplication or division. We've got multiplication, so we need to divide by 6 on both sides. The 6's cancel. We bring down the a, and then before you bring down your inequality, ask yourself, did we multiply or divide? Yes. Did we multiply or divide both sides by a negative number? No. So the inequality sign stays the same, and then 12 divided by 6 is 2. Now, just like before, you've got to check the answer and check the inequality. So, we think that the answer is a is greater than negative 2. And first on the left-hand side, we're just going to check the answer. So 7 plus 6 times 2, I want to see if that equals 19. So over here we would do multiplication first. So 7 plus 12, that's 19. Over here we have 19, so that's a true statement. Now we want to check the inequality. So we want any number that's greater than 2, 3, 4, 5, whatever. So 7 plus 6 times, let's just do 3, and we want to make sure that that's greater than 19. So 6 times 3 would be first, so that's 7 plus 18. And then 7 plus 18 is 25. That's greater than 19, so this is correct. Now you should check every answer to guarantee that you did not only the mathematical portion correctly, you should also check to make sure you did the inequality sign correctly. However, for the sake of time, I'm not going to check every one of these. We will do 3 more examples together, but I will not check the answer. So the next example, adding a couple more steps now. So first, separate the two sides. Use the distributive property. Well, we know we need to do that this time because we've got parentheses and we cannot add t plus 2. So I distribute that 2 to the t and the 2. 2 times t is 2t. Bring down the plus sign. 2 times 2 is 4. And then just bring everything else down. Combine like terms is the next step. So let's look on the left. Well, we have a 2t and a 3t, but I need to circle that minus sign with the 3t because it's right in front of it, so that would be negative 1t. Bring down the plus 4, and then bring everything else down. We did step 1, we did step 2. Step 3, gather variables on one side. They're already on the left. There's none on the right, so I don't need to worry about step 3. Step 4, undo addition or subtraction. So I need to move the positive 4 by subtracting 4. Bring down the negative 1t. 4 minus 4 cancels. Bring down my sign, and negative 1 minus 4 is negative 5. I still do not have t by itself because I have the negative 1 attached. It has to be positive in order for my answer to be completely done. So that is attached with multiplication, so I will divide by negative 1 on the left and on the right. That way the negative 1's cancel. I have t by itself. But before you do this last step, ask yourself, did we multiply or divide? Yes. Did we multiply or divide by a negative number? Yes, we did. We divided by negative 1, so my sign will flip. And then negative 5 divided by negative 1 is positive 5. So the answer here is t is less than or equal to 5. You would then take the 5, plug it back in your inequality, and check if you did the numerical answer correctly. Then you would pick any number that's less than 5, so 4, 3, 2, 1, plug it in for t. Actually, you could pick 0. 0 would be very easy to check, very fast, and you would see if that was going to be greater than or equal to negative 1. But right now we're just going to move on to the next example. If you have questions about how to check it, I can answer it tomorrow in class. So the next example here, let's check if we need to use the distributive property. Well, we don't have any parentheses on the left or the right, so I don't need to. Can we combine any like terms? Well, on the left we have a z and a number, so we can't. On the right we also have a letter and a number, so we cannot combine any like terms. We want to gather the variables on one side. I forgot to separate my two sides, so let's go back and do that. Remember, I told you if it's easier for you to work with positives, it really doesn't matter. But if it's easier, you could just always move the smaller variable, which in this case would be the 4z, because 4z is less than 6z. So let's move the 4z to keep it easy. Doesn't matter if you move the 6z though, either way. So in order to move the 4z, I've got to ask myself, how is the 4z attached to the 11? It's attached with addition. That means in order to undo it, I'm either going to add or subtract 4z. But I need to look in front of the 4z. Since it's a positive 4z, I want to do the inverse of that and subtract 4z. And then whatever I do on the right, I do on the left. And I want to make sure I'm lining up my like terms here. That way 6z minus 4z is 2z. I bring down the minus 15, bring down my sign. 4z minus 4z cancels, and then bring down the 11. Now I have all the variables on the left-hand side. So I want to undo addition or subtraction. I've got to look on the side with the variable. The variable's now on the left, so I want to move the 2 and the 15. The 15 is attached with subtraction, so that's the one I want to move first. Since it is a minus 15, I'll do the inverse and add 15. Bring down the 2z, negative 15 plus 15 cancels, bring down the sign, and 11 plus 15 is 26. And now the 2 is attached to the z with multiplication, so we are going to divide by 2 on both sides. But before we do this last step, remember, ask yourself, did we multiply or divide by a negative number? We divided by positive, so my sign stays the same, and 26 divided by 2 is 13. So the answer is z is less than 13. Again, you would want to check this and plug in 13 and make sure this side is equal to this side. And then you want to pick a number that's less than 13, so 12, 11, 10, 9. Like I always say, you could do 0 because that's less than 13. That's always an easy number to do. And you would plug it in and see if this side is less than this side. If it is, we did everything correctly. Last example here, combining everything together. So separate your two sides right away before we forget. Use the distributive property. So I've got parentheses on both sides. I've got to do that twice. So over here, distribute the negative 3. Now this is where it's going to get confusing because it's easy to see, okay, negative 3 times 4 is negative 12, but is this a negative 3 times a positive m or a negative 3 times a negative m? So this is the time I want you to change this to same, add, opposite. So 4 stays the same, this becomes a plus, m becomes negative. Because now I could see, okay, I'm bringing down a plus sign, and then negative 3 times negative m would be positive 3m. Okay, bring down the sign. We need to do the distributive property on the other side as well. These are all positive, so I don't have to change anything. 4 times 2m is 8m. Bring down the plus sign, and then 4 times 1 is 4. Okay, step 1 is done. Step 2, do we have any like terms on the left? Nope, we got a number and a letter. On the right, we've got a letter and a number, so we don't need to worry about that. Step 3, gather the variables on one side. This time the 3m is smaller than the 8m, so let's move the 3m to keep with the positives. So since it's plus 3m, it's attached with addition to the negative 12. It's positive, so I need to subtract 3m on both sides. Bring down the negative 12. 3m minus 3m is 0, which is what I wanted. Bring down my sign. 8m minus 3m is 5m. And then bring down the plus 4. So we did step 3. Step 4 says to undo addition or subtraction. First you want to look for the variable. Remember, the variable's on the right side here. We don't want to add or subtract the negative 12. We want to get rid of the 4 and the 5 on the side with the variable. So the 4 is attached with addition, so I will subtract 4 on both sides. So negative 12 minus 4 is negative 16. Bring down my sign and bring down the 5m because the 4 minus 4 cancels. And then the last step is to undo multiplication or division. So since this is 5 times m, I will divide by 5 on both sides. And then negative 16 divided by 5 is negative 3 1/5. And then before you bring down the sign, ask yourself, did we multiply or divide by a negative number? No, we did not. It was positive, so my sign stays the same. The 5's cancel and I bring down the m. This would be a correct answer, but remember we typically put the variable first. So let's put the m on the left and the negative 3 1/5 on the right. But since I flip-flopped the sides that they're on, I need to flip-flop the inequality symbol. So these two things here and here, they mean the same thing. But typically you see the variable first, especially if it's a multiple choice test. So you want to be able to reverse it so you know which answer is correct. All right, that's all the examples for solving multi-step inequalities. If you have any questions, I'll answer them tomorrow in class. Bye, guys.